In this lesson, we'll look at attaching the Chat UI user interface to the network. To do this, we need to understand a little about the TCP/IP network system and how the Java libraries interact with it. At its simplest level, the network is quite a bit like a phone system. In this situation, one party is waiting for the phone to ring, and the other does the ringing. In the network, the program that is waiting for the phone to ring is called the server, while the one that does the ringing is called the client. Let's take a look at the code. Here is the server code, and you'll see that the first thing it does is to create this object called a server socket, and its parameter for the constructor is a number. This is called a port number. This is a lot like the extension number in an office telephone system. The client, by contrast, makes a connection to what amounts to a phone number and the extension. The phone number in general is actually going to be a DNS name, so for example something like video2brain.com. However, our example, we're going to want to have both the client and the server connecting on the same machine so that we can run everything locally. And it turns out that 127.0.0.1 is a magic number which says connect back to your own host. It's called localhost in some systems, but that's not very reliable in Windows. So here on the client, when we create this socket, we are effectively making a phone call to our own machine, but connecting to the extension 1234. On the other side of that connection, here we tell this program to listen to the extension 1234. We don't have to specify a phone number because obviously we're already inside the building. So we're listening for our own phone to ring. In the server, once we have set up this server socket, we then have to effectively tell the receptionist to answer calls. And this ss.accept call, the accept call on the server socket, does that. When ss.accept returns, it returns an object of type socket to us. And a socket is very much like the telephone handset. If we look at the client for a moment, you'll see that we actually created a socket directly by connecting it to a phone number and an extension. So now, in fact, both the client and the server are connected using this exact same object type called socket. And a socket's essential job is to embody an output stream that we can send data down and an input stream that we can read data from. Of course, we're familiar with the mechanisms that Java uses for reading and writing data on an I/O channel. So it shouldn't be a big surprise to see that the next thing we do is to create a variable called input of type buffered reader. The buffered reader is connected to an input stream reader. Remember that that converts 8-bit bytes into 16-bit characters, and it in turn gets its character stream from the socket. So s.getInputStream. The getInputStream method on a socket gets hold of an 8-bit byte stream that we can read characters from. Those characters are the characters that were sent from the other side of the network. We do the same thing in the server side. Exactly the same thing, because we're dealing with a socket again. If we look back at the client, the next thing we do is we get the output channel of our socket. That is s.getOutputStream. We wrap an output stream writer around that to allow us to write 16-bit characters to it, and the same happens on the server side. Exactly the same code. The client creates the Chat UI window with the label client end and a connection to the output writer. It then goes around reading lines from the input. Those will be messages received across the network, and for as long as we are getting messages, it appends those messages to the text area in the Chat UI itself. When it reads a null, the null indicates that this socket has been closed, and that will cause it to drop out of the loop, and then it will send the message to our text area that says connection lost. Unsurprisingly, the exact same thing happens on the server side. And that's all there is to getting basic networking going. So let's run this. We'll want to start the server first because remember, it's the server's job to be listening for connections. If the server isn't listening when the client makes the call, the client will fail because it gets no response. So we'll start by running this one, and we will right-click and run file. Notice that we actually have 3 executable programs. We have our test program, and then the server and the client pieces. So we must use the run file option rather than hitting this green button, because this green button is going to start the test piece. We don't need that. So now we'll select the chat client, and we'll right-click, run file. So this is going to make the phone call. And as it does, the server is able to respond, it pops its user interface up, so does the client. Now if we type things into the client side, the message appears for me on my own log and appears on the server end. And if we type in the server end, similarly the messages go back the other way. So problem solved. We now have these 2 instances of our chat UI connected to the network connecting them to each other. In this example, both ends of the network are running on the same machine. But if we close these, all you would need to do to make this work across machines is for one machine to act as the server. So you'll just run this program exactly as it is, unchanged. And then on the other machine, you'll run this program and you'll modify it so that this field contains either the IP address of the machine. If you're running a home network, that's likely to be something like 192.168.something.something, but you'll have to look at your own network to work that out. Or possibly a DNS name, so mymachine.com or something of that sort, depending on how your network is configured. And there we have it. In this lesson, we have put together our chat UI GUI elements with a network socket and created a real network client and server program pair so that we were able to send simple text messages between 2 different running Java programs.